Hello everyone, welcome. So, we were talking about matter, which is the first chapter of science as per as CPSC. Now, we have already discussed what is matter. Matter is anything that occupies space and has mass. We have already talked about the characteristics, features of the particles of matter, which is matters consist of very tiny particles. These particles move continuously or they are in continuous motion. There's space between the particles of the matter. And lastly, we have also told that the particles of the matter, uh, mm, you know, we already have told they attract each other. The particles of the matter attract each other. Now we are coming to, in this topic, in this video, we will be talking about the states of matter. So there are different states of matter. We know matter can be solid, it can be liquid, it can be gaseous or gas. So when I talk about solid, what I say, the particles of the matter, they are very closely packed or densely packed. So if I, uh, they are very closely packed. The particles of the matter, they're very closely packed. In liquid, they are less compact. Okay, they are less compact. And gaseous, they are very loosely packed. Gaseous are very loosely packed. So solids are tightly packed. Liquids, they have a package, whereas gaseous, they are very loosely packed. Okay, so these are various types of matter we have. Now, when I talk about the solid, see if I'm able to move my hands very easily in the air. Now, if I have take a bucket of water and then I try to swirl my hand. So if I swirl my hand, what will happen? I will feel some kind of things maybe stop trying to stop my hands from getting swirled. Okay, initially you would see this. Whereas if there is a solid particle and I want to move my hand through, I cannot do this. This is basically because of the densely packed of the particles. When the particles are densely packed, what is happening? The space between the particles becomes too less. Hence, I'm unable to move my hand through any solid particle. This hand is solid, this hand is, I'm trying to move it. So I'm not able to move it. Okay. So the attraction between the particles is too high when I talk about solids. In liquids, it's lesser and it is least in gaseous. So liquids, what happen? We have water. We pour it into a glass, it takes the shape of the glass. We pour it into any other vessel, it takes the shape of the vessel. It has a mass, it takes some space, but it is there. Whereas gas, what has happened? Whichever container is empty, it is not empty, it is actually filled with gases. So the container, if I have half a glass of water, the rest half a glass is empty. No, it is filled with gas. So the gases, it is free to move around. Hence, I can pour, I can do anything with the glass of water that I'm having. Okay, you would find this. All right. So these are various states of matter. Including these states of matter, we also have another few states of matter. What are the other states of matter we have? We have a plasma state of matter. So our blood has got a plasma. Okay, it has got a plasma. So if you keep our blood, if you see when it gets settled down, okay, if I take the blood in a test tube, so later at some point of time you will see the blood has got settled down, and here there will be a colorless liquid that is the plasma. Okay, and other we have the Bose-Einstein condensate. Bose-Einstein condensate. So this is when the particles are compressed too much, then what happens? It gets separated into charged photons and neutrons. So they will start communicating charge. Actually, these particles are neutral; they do not have charge. But Bose, Einstein, condensate, they are charged. Next, I would tell: can I change if I have a solid phase, liquid phase, and gaseous phase? Can I change? Yes. In case of water, I'm telling ice can be transformed to water, water can be transformed into steam. So if I transform solid to liquid, it is known as melting. Okay. Liquid to gas, it is evaporation. Okay. Then the vice versa, gas to liquid, it is condensation. Liquid to solid, it is freezing. So I have told about melting. Melting is the process of conversion of solid to liquid. Then I have talked about evaporation. Evaporation is a process to convert liquid to its gaseous form. Talked about condensation. Condensation means conversion of the gaseous state to the liquid state, and freezing is conversion of the liquid state to the solid state. Now, if solid gets converted to gas directly, it is known as sublimation. And the opposite is known as solidification. So, conversion of gas, solid to gas, like camphor. So it doesn't pass through a liquid state. It from the solid state, it gets converted right to gaseous state. So that is known as sublimation. And if the gaseous state suddenly forms solid, like dry ice and all those, it is known as solid liquid nitrogen. So that is known as completely solidification that is going to happen. Okay. So these are so the whole chapter consists of the matter, the states of matter, and the conversions of the matter. Here, there are a few more things that I would like to bring to your notice. That is, whenever I am talking, whenever I'm telling about the change, I'm talking about something called as temperature. Temperature is nothing but the measurement of heat. Measurement of heat. Temperature is measurement of heat. So, whenever I talk about the temperature, so I have got the temperatures. I can take the temperatures in three different. One is degree Celsius, one is degree Fahrenheit, and one is Kelvin. So, if I have Kelvin is equal to degree Celsius plus 273. Okay. So if I'm telling that water freezes at 0 degrees Celsius. This is equal to what? 0 plus 273. That is 273 Kelvin. If I talk about water boils at 100 degrees Celsius, this is 100 plus 273. That is 373 Kelvin. All right. To convert Celsius to Fahrenheit, what is it? Fahrenheit is equal to 5 by 9 C plus 32. So this is the conversion that we would have. We have it as 9 by 5C. So now from where this 9 by 5C comes, it's not a matter of by hearting. So if I have Celsius, if I have Fahrenheit, then There is 100 divisions for Celsius, whereas there is 180 divisions for Fahrenheit. So, for a Celsius to be X degree, what will be its Fahrenheit? 180 X divided by 100. If I cut this, it was 9 by 5. So I have 9 by 5 C, and plus 32 is at 0 degrees Celsius Fahrenheit, it is 32 degree Fahrenheit. Hence plus 32. So this degree Fahrenheit to degree Celsius is 9 by 5 C plus 32. So these are the conversions. Questions may come to convert from one form to another. So that can be practiced up. Another thing that we will be talking about is heat. I am talking about the latent heat. Latent heat means what? It is the amount of heat required to convert 1 kg of substance from one form to another. Or if I say latent heat of vaporization, then it is to convert vapor. When I say about vaporization means liquid to solid. So latent heat of vaporization would mean the amount of heat which is required to convert 1 kg of liquid to the steam. 1 kg of liquid to the steam. Okay. So latent heat of freezing, again, if I say latent heat of freezing, then this would mean how much I convert 1 kg of liquid to the solid form. Okay, so this is what is latent heat. So latent heat, I can give it as Q is equal to mCp delta T. So the mass which is there, mass may be 1 kg of which is required. Cp is the heat capacity that is there, and change in temperature. What is the change in temperature? So this is the thing that I